After the test, this is an assignment that's an extension of solving equations with radicals. This is the other direction. Instead of square roots here, there's things that are squared, and we're going to take the square root. IB calls it forcing the square root to find the solution. So the thing you want to make sure of is that your variable is isolated, or in the case where there's a quantity, whatever's being squared is isolated, put by itself. So I'll do a couple examples of them up here. So I'm going to do 1b. 1a is pretty straightforward. 2x squared equals 50. I divide both sides by 2. X squared equals 25. Take the square root of both sides, and you get plus or minus 5. So you notice when we go this direction, we have two solutions, because when you square a negative, it becomes positive. Okay, so that would take you through all of these examples. I'll do H. Again, your goal is to isolate the variable, or the term being squared. In this case, it's just the variable. So I have negative 2x squared equals 8. X squared equals negative 4. Now, when we go to take the square root here, the square root, we know the square root of negative 4, we just got doing that as 2i. So I really have plus or minus 2i. And on this page, they talk about that as just no real solutions. Since we've been doing imaginary numbers, you can go ahead and find the imaginary solution, the complex solution, and work with it that way. So if you wanted to check, you go back and put in, if you put in 2i right here, 2i squared is negative 4. 4 minus 2 times negative 4 is 4 plus, and negative 2i also works. So if you have an imaginary root, go ahead and write it as imaginary. And in the case of a radical that is not a perfect square, if you can simplify the radical, simplify the radical. Okay, so the second kind is we have a quantity isolated, and you treat it just like a square root, or an x squared. So I have x plus 4 squared equals 16. The quantity is already isolated, so I'm going to take the square root of both sides. X plus 4 equals plus or minus 4. And that is important to get your solutions. Make sure you have plus or minus. So I subtract 4, and I have negative 4 plus or minus 4. So my solutions would be negative 4 plus 4, which is 0, and negative 4 minus 4, which is negative 8. And quick check, negative 4, or 4 plus 0 is 4, square root of 16. Negative 8 plus 4 is negative 4, square root of 16. In the case of like letter G, 2x minus 5 squared equals 0. The quantity is isolated, square root. 2x minus 5 equals 0. You can do plus or minus 0, but it doesn't have two different values. So 2x equals 5, x equals 5 halves. Down below, no, I just realized this copy is messed up. I'll get you another copy. Just a second. Okay, I just added a couple additional problems. This is what we did before, just to review and showing you the connection. If you want to go ahead and pause your video right now, you can work these three out and then check it again. So what I want to do here is isolate the radical so I can square it to get rid of what's there. So this is similar. You're just at the other end of the isolation. Opposite of taking the square root is squaring. So if you, again, seeing the similarities, isolating the squared quantity or isolating the square root. Divide both sides by -2, square. A equals -10. Divide both sides by 7. Square. And divide by -48. So these are pretty straightforward. For some reason I have the same thing on there twice to give you more space. I didn't clip that. The 3 problems at the end. Check for Khan Academy as well.